Hello my friends and welcome back. This is the video number 6 of my Ultimate Ladybug course. In the last video we looked into wind speed, wind profiles. We also plotted a wind rose, which was quite interesting. We also tried to modify the original wind data so it's maybe more realistic for our modified or recreated weather data. And then we also learned that weather data coming from airports normally are captured at a level of at an elevation of 10 meters height. So we can take that into account if we then later on measure, for example, the outdoor comfort on a different level or a different elevation on the ground, for example. Having said that, outdoor comfort, that's exactly what we're gonna look into today. I did a lot of videos on outdoor comfort and indoor comfort with Ladybug, Honeybee, even combined with Butterfly and so on. I can put some of the videos into the show notes. They're quite interesting, but this video gives you the basic understanding. This video is a starting point of more complex scripts where we try to add more stuff in the next videos. Before we jump in, I have to announce 2 new members. We have 9 days ago Scott Northcutt joined my channel as a member. Thank you so much for joining. It's a pleasure and it's an honor. Scott has also a YouTube channel, and what can I say? He only subscribed to me, so I'm the only channel he subscribed to, which is it's epic. Probably you just joined YouTube only to support me. I mean, that's what can I say? You know, it's really amazing. And then we have really just yesterday, today actually. Depends when I publish the video, but probably today. Akil also joined my video just today. He also has a YouTube channel and he has a video. It's about low-income housing in Sambad. Not exactly where, in India, I think. So I found several Sambad in India. And it's an interesting video because it shows kind of the reality and the aspiration of a slum area, basically. It's devastating images. But what I really like of that video is the epic soundtrack, which basically shows then some solutions to the problem. I think it's really interesting. I'm not 100% sure what... I mean, I think there should be more explanation to that video, so I placed a comment here. So I hope I get an answer. I said, hey, this is quite interesting. Can you tell me more about the video and the project? So Akil, by the way, he sent me a question asking for a script. I will try to dig out the script. I haven't found it yet. But I just want to say that I stopped sharing scripts because they just led to more confusion. Just caused more work for me at the end. I also got the feeling that some of my subscribers just they don't want to watch my video to learn something. They just want to get my script. But for members, of course, I make an exception. So members can ask me. I will try to find it, Akil, and hope I can just send me an email and I can transfer it to you. Then I can send you a link, or I can just send it directly to you. All right, let's jump into Ladybug thermal comfort. Hey. Yes, so okay, let's dive into Grasshopper and Rhino. As you remember, I work on this project in Rwanda. I explained already in the previous videos. If you haven't seen these, then please go back. We cover quite a lot of stuff. In the last video, we looked into wind speed and the wind rose and also the wind profile. So we built this script over the last couple of videos. If you have a weather data which is very close to your site, you can just use that for this next steps. You don't need to really modify it. What I showed here was on how we can modify a weather data which is a little bit further away, but the closest we can get. And we changed some elements of it because the location of our project is first of all, it's like I think around 60 kilometers off. The elevation is 300 meters higher. And as you can see, it's on a ridge. The wind speed also might be stronger here. Nevertheless, if you have a weather data, you can just jump right in. If you want to modify your weather data, please check the other videos, the older videos. So these are just basically blocks we studied. I just cleaned up a bit. Items we checked before, or we already looked at before, like for example the wind profile is all here, combined into groups. Here we have the windrows, and then here we have other charts which we looked at. And we also looked at how we can create like analyze periods. We will cover these items again and again. They will come always in every script. You will need similar, basically the portion where we are at the moment. These are really the basics, and we went through all kinds of stuff already. Last time we looked at the Ladybug degree days, then the wind speeds, and we also had a preview on hourly plots, monthly plots, the windrows, and so on. We will go there again because I want to like cover everything, but then also depending on what we're testing, and we try to test as much as possible so get a really good understanding. Let's continue. We are here at the adaptive comfort. There's adaptive comfort, there is the PMV comfort, there's the PET comfort, and there's the UTCI comfort. I'm most familiar with the UTCI comfort, and that's what we're gonna start with. Okay, let's just get the tool. I just get the tool here first. Just place it here. And again, this is my modified weather data. You can use just any weather data online. So I could replace all this here, all this what you can see here. I could delete and then just work with the weather data, the original weather data. It's just a modified version. It has the same outputs. It's just my modified version that fits better to this site. All right, so the UTCI, as you know, like all the inputs it's always the same. So if there's an underscore at the beginning, it's mandatory input. You need to put something in. If there's an underscore at the beginning and at the end, then it is mandatory, but it has a default value. And if it has only an underscore at the end, which can also happen, then it's optional. It's an optional input. I'm starting with the UTCI because it's easier than the others. It has less inputs than the others. If we compare these, the UTCI, the outdoor comfort, and we get there right away. We will discuss that in no time. Has the least inputs, and it's therefore also the most easiest to put together. All right, so yeah, it has here the air temperature. Air temperature goes in here. Then we have what else is required? The relative humidity is required. The MRT, the mean radiant temperature, is not. It already has some values here. Yes, so default. If we don't put anything here, then it assumes the default is the air temperature. Let's see what we can do here. All right. Then we have the relative humidity that goes in here. The wind velocity is an optional. And then we can put here a toggle, a Boolean toggle, just to turn on and off the calculation. So we can put this here. Now it becomes gray. There's no output yet, and we can set it to true. So what's the UTCI? UTCI stands for Universal Thermal Climate Index, and it's basically trying to estimate the perceived temperature. So, for example, if the air temperature is very hot, it's hot, but the relative humidity is low, then it doesn't feel as hot as if it would be very humid. So, for example, if you have, let's say, the air temperature is 21 degrees, but my humidity is very high, then it might feel much hotter than it is. It might feel like 25 degrees. So that's what the UTCI tries to calculate. And then there's a range, and we can go through the text actually. So calculate the Universal Thermal Climate Index. UTCI is a thermal comfort model strictly for the outdoors. It is an international standard for outdoor temperature sensation. It feels like, also called feel-like temperature, the perceived temperature, and it's one of the most common of such feel-like temperatures used by meteorologists. The UTCI that attempts to satisfy the following requirements: thermophysiological significance in the whole range of the heat exchange conditions, valid in all climates, seasons and scales, useful for key applications in human biometeorology. While the UTCI is designed to be valid in all climates and seasons, it assumes that human subjects are walking with a metabolic rate around 2.4 MET, and that they are naturally adapt their clothing with the outdoor temperature. For the outdoors situations that do not fit these criteria, the physiological equivalent temperature PET model is recommended. So we have two models which we can look at. Now, in order to make this even more exciting, let's first put an hourly plot here, and let's use the UTCI here. This is the perceived temperature output. Oops, that was quick. And we add a base. I already prepared some places here for new charts. Maybe we push it a bit further here. So it looks very similar as the yearly temperature chart. So that was pretty easy. Now we can add more here. We can add the mean radiant temperature. What does that mean? So that is it's basically the trying to estimate the surrounding temperature of the objects around you. So the ground, what kind of depending on where you are, of course. So that's actually tricky in our case because we moved from an airport to the countryside. So let's see how that works out. But also the wind velocity is interesting. So we can add two more things to make this more interesting, and also to compare then the result. Let's I copy this. Oh, sorry. Copy, paste, so we can see if there's any difference, and then we place this second one here. Maybe also would be good to just place the temperature, which is the dry pulp temperature. We can place the chart here. Maybe it's also a good idea to place that here so we can see kind of a difference. I'm gonna get rid of these dimensions here so it has the same size. But what we could do is we could place a maximum and a minimum so we can actually see the difference. I will just copy this. Or let's say, what would be the maximum here? The minimum is 10 degrees. The maximum here is 32 degrees. Here, the minimum perceived temperature, that's the result of on how it feels, on how the temperature feels like because of wind, because of the humidity. And interestingly, when it's quite hot, it doesn't feel as hot, probably because of the wind. So I take this and make a copy. So now we have the UTCI, where we just take the minimum required input. Then in the second one, we will add the mean radiant temperature and also the wind velocity and see how that changes. Now legend parameters. So let's keep it more open. So it means we add a bit more, create a larger range. And that we can then use here legend parameters, and legend parameters here. And now we see that actually we see quite a difference. I'm gonna disconnect that once more because I want to check something here. Okay, that's 26 and oh, okay, I understand. So this we need to. I just disconnect this for. Oh no, it's just here disconnected. Just want to see. Okay, 27. This is the maximum here, between 7 and 27. So we could make it a bit lower here. Let's say 32 or 30 is the maximum, and 0 is the minimum. It seems like nothing is actually as low as 0. So maybe we just increase here a bit. There's not so much difference really between this and this. It's very, very similar. So we can't see that much difference yet. And we will see if we can later on when we add the wind speed. So what can we get here? The mean radiant temperature. What is that? As I said before, this is like what is in very simple terms, it's the influence of your surrounding on the temperature. And let's get this tool here. So there's a tool for this. It's called the Ladybug Outdoor Solar mean radiant temperature. Calculate mean radiant temperature as a result of outdoor shortwave solar shining directly onto people as well as long wave radiant exchange with the sky. This component uses this. Actually, these tools are very similar, indoor and outdoor. Let's put this here and let's see what we need. So first of all, we need the location. And let's put this right in. So I want to see immediate difference. As soon as I put this in, I might get quite a different output here between these two. Okay, so we have location. Let's see if this changes anything. Doesn't change anything yet. Oh, we also need a run button here, of course. And we have items we need to provide, otherwise it doesn't work. Surface temperature. This is really difficult to know. We don't know the surface temperature really, but it says here, a single number of an hourly data collection with the temperature of surfaces around the person in degrees Celsius. This includes the ground and any other surfaces blocking the view to the sky. Typically, outdoor dry pulp temperature is used when such surface temperature is unknown. So we don't know the surface temperature, so that's why we use the dry pulp temperature. That's what I can put in here. Then the direct normal radiation. That we can get from here, direct normal radiation. There's no change, by the way, because it hasn't run correctly. We need to have diffuse horizontal radiation and the horizontal infrared radiation. Then it will start to calculate diffuse horizontal radiation and the horizontal infrared. And now it should calculate. That is a huge difference. Let's see why. And it seems like there's is a much higher temperature. Now I slowly believe that we are in Africa. I will just very quickly disconnect here because I want to know what is the actual temperature. So 33 is kind of the maximum, 34. Let's put here 35 as a maximum. So this was the outdoor comfort calculated only from the air dry pulp temperature and the humidity. Now this adds all kinds of other stuff. The problem now, what we're facing is that this is data which were gathered from the airport. That could have changed quite a lot, but let's assume we have roads there, we have similar surfaces. That's what we get. We have maybe a concrete slab, and we have a similar output here. Now, what else can we add here? This is not all. That's not yet all what we can add. There's more. So, for example, we can add here the mean radiant temperature. We added here. That's good. There's also the wind velocity. Now we could here get the wind speed. So it should work if we put this in here. That makes things again totally different. As you can see, that's also super interesting that this now changes dramatically. As soon as the sun is up, it becomes super hot, and the wind actually changes quite a lot here. There's more wind coming, more wind in the morning, in the night. It seems like. So that's what I understand now from temperature. Again, let's check if this has an influence on the temperature. We might need to adjust that here again. There's some areas that are really red, and maybe we need to go lower with our temperature also. So let's go here, -10. So we have a bit of a play. Anyway, we can always check what the minimum and maximum is. There's another way also to do that, just to go here and deconstruct data and then just sort list. And that also gives me an understanding here. How much, what's the range here? Okay, 33.6 is the maximum, 33, 44, and then -12. I don't think that actually happens. I don't think this is a correct number, to be honest. Sometimes if there's a problem with the data, that could cause that. I don't buy that really, that we have -12 degrees. But overall, I think it tells us something. It tells us that the wind has definitely some influence. Now, what else can we add here? The fract body exposure, a single number between 0 and 1, or a data collection for the fraction of the body exposed to the direct sunlight. The Ladybug human to sky relationship component can be used to estimate this input for a given set of context, geometry, and position of the human. Note that this parameter does not include the body's self-shading. It only includes the shading from furniture and surroundings. So what we can input here is basically a number between 0 and 1, or we can input the relationship between the human to sky. And that then allows us to add a structure, for example. So we could take this and place an object as a shading device onto my site. That then gives us some idea. Let's be careful with this. We will get there. We will not use that. We use just here the default, which is 1. It's just open area, and that's basically it. I mean, it is very open. We can check the sky exposure. This is also an output from this tool. So if you look here, it has the fract body exposure and sky exposure. But for that, we will get there. So this is analyzing geometry. We'll have a look when we get there. So first, let's just understand the weather data and how we can use it. So that, because at the moment we don't have really structure here. That comes with the design, right? Ground reference, that's actually good because we can change how what's in here relates to the ground, because we have mostly bare soil and grass here. So this is just a farmland, and that's good. So we can actually specify something here. A single number between 0 and 1, or a data collection that represents the reflectance of the floor. Default is 0.25, which is characteristic for outdoor grass or dry bare soil. Okay. Let's test what actually comes out here. If we, let's 0.5, and we put this in here, we need to look at the chart. So let's see if there's any change. If we put this to 0.25, I will get rid of the legend parameters for a bit. I just want to see how this changes the overall numbers. So again, if I change this here, it does change something. I would say it's not grass, it's farmland. There could be higher plants, and I'm just speculating here. And put maybe 0.12. So it's actually wet. It's not necessarily dry soil. And that kind of lowers the temperature a bit. So it might be maybe more correct. Okay, what else?